Delete in linked list. Deletion in a linked list is the process of removing one particular node from a linked list. If you have a linked list and you want to delete one particular node, depending on the position of deletion, the procedure will have slight changes. Let us see what is the difference in each position. There will be a head pointer which is pointing to the first node of your linked list. After that, each node will have a next pointer which will point to next node in the linked list. This is how you keep track of all the nodes. Let us put some numbers here. The first node, let it have 15, second one 21, then 10 and 17. Let these be the values. And what do we have to do? We have to delete some particular nodes from this linked list. We'll start with the easiest case, that is deletion at the beginning of your linked list. This is the easiest case. Whenever we are talking about deletion, keep one thing in mind, that is, in case your list is empty, always treat this as a special case. What do you want to do in this case? You can't go forward with any deletion because your list is not having anything. What will you do? You have to just abandon the delete operation and return whatever is the head pointer. How are you going to identify that your list is empty? How are you going to identify this? For this, you have to look into your head pointer. I told you that whichever be the first node of linked list, that will always be pointed by the head pointer. In case your linked list is empty, your head pointer has nothing to point to. So, your head pointer will be null. Whenever your head pointer is null, understand that your linked list is not having any elements. What should you do? You should abandon delete operation and return head pointer, that is return null. Otherwise, that is, in case there are some elements in the linked list, then let us discuss how to delete each particular position. The first case is deletion at the beginning. That is, we want to delete this node which is having value 15. How are we going to delete this? For this, think of one thing. I told you, head pointer will always point to your first node. In order to delete the first node, what do you want to do? You want to make whatever is presently the second node as the first node. If this becomes the first node, that is as good as removing the first node. So what can you do? Your head pointer will tell you which is the first node. So if you make your head pointer to point to the second node instead of your first node, this would mean this will be considered as the new first node. So your second node, whatever was previously the second node, this will now be considered as the first node. So your first node is as good as not existent. But there is something to be taken care here. The point is, given that you are changing your head pointer to the second node, there is no way of accessing whichever was previously your first node. If you see here, there is no way of reaching 15 now. The only way of reaching 15 was through your head pointer, and now you have removed this and made head pointer to point to 21. So 15 is not reachable at all, and it will stay in your memory. In case you are using a language which is not having automatic garbage collection, let us say you are using C or something, then it is always advisable that you keep track of whatever you want to remove and you explicitly free that memory. That is, before you moving this head pointer, what should you do? Initially, when the head pointer is pointing here, use a temporary pointer. Let us say a new pointer, you call it a temporary pointer. Make this point to whatever you are going to delete, and then after this modify your head pointer. Make your head pointer point to the next one. The advantage is, even after you moved your head pointer to the next one, you have some way of reaching the node which you want to delete. At this point, now that you have moved the head pointer, from the list it is deleted. That is, in this list which is pointed by the head pointer, there is no way of reaching 15. That means it is deleted from the list. But this is staying in memory. What do you want to do? You want to explicitly free the memory by, let us say, by free operation. You will do free of the one pointed by temporary pointer. By this, you will be able to remove this usage of memory. That is how you complete your deletion operation. Again, this is dependent on the language you are using. You have to do this explicitly if you are using a language which is not having automatic garbage collection. Okay. So this is how you do deletion at the beginning. You have to simply move the head pointer to the next node. This is the procedure. Always when you are deleting, whichever be the node you are deleting, keep track of that with a temporary pointer and free it. This is a good practice. Okay. This is the first case of deletion at beginning. What is the time complexity of this operation? Time complexity is order of 1 because you are not considering whatever is the size of your linked list. That is, if there are n nodes in your linked list, your deletion is not dependent on the size of your linked list. You simply have to go to the first node and make this head pointer point to the next. It is a constant time operation. Your time complexity, it is considerable only if it is varying according to the size of your linked list. That is, if this linked list size is n, then as n increases or decreases, if your time will also increase or decrease, then only you have to count that time complexity. Otherwise, it is a constant time. So here, because it is not depending on n, you will call it constant time. What about the space? In case of insertion, you at least used that additional space for creating new node. But in deletion, you are not even using that. So space complexity is constant, order of 1. There is no additional space used. Space complexity is constant. This is it about deletion at the beginning. What is the second case? Second case is deletion at the end. In all the cases of deletion, keep in mind that if your list is empty, that is always a special case. You can't do any deletion. Whatever cases we are discussing, this is by considering that there is something in the linked list. Okay. How can you delete from the end? If you want to delete from the end, that is this particular node with value 17. If you want to do this, first step is start from the head pointer, go to the first node and keep traversing your list till you reaches. Should you reach till the end? This is the big question. The answer is no, you should not go to the last position. Instead, you should stop your traversal at the second last node. How do you understand that this is the second last node? For this, how did you previously understand when it was the last node? When we learned about insertion, we had to check for the last node. So how did we understand that we reached the last node? For that, we were checking the next pointer of this node. For every node in the linked list, the next pointer will be pointing to something. But for the last node, there is nothing to be pointed to. So the next pointer of the last node will be null. This is how you were able to identify the last node. This time you have to identify second last node. So what will you do? In order to identify second last node, you have to see the next of the next. That is, from here, if you see next of next is 0. Next is pointing to 17. If you are standing at 10, that is second last node. From here, next is pointing to 17, which is the last node. But next of next is null. In order to identify the second last node, you have to see whether next of next is null. If this is null, this is a second last node. So as far as deletion at end is concerned, you should stop this traversal at the second last node. And then what should you do? Your next pointer should be set to null. Presently, you are having a last node because of which second last node is pointing to something. But if this is not present, then what will be the scenario? Your second last node will have next pointer as null. So in order to remove the last node, what can you do? Go to the second last node and make its next pointer as null. One more thing, the same thing that I told in the previous case, before you make this null, keep track of this with a temporary pointer. After this, make this null. Null means remove that pointer. Once you make it null, you have track of the node to be deleted using temporary pointer. Now you can free this node using the temporary pointer. This is the best practice. Otherwise, if you simply remove this at that point itself, it is considered that the node is deleted, because if you remove this link, then there is no way of reaching 17. So from this linked list, you have already removed that particular node. The best practice is after that you have to free the node. That is in case your language is not having automatic garbage collection. Next case is one more thing. What is the time and space complexity here? When you remove the last node, for time complexity, you should see what is the worst case scenario. You have to start from the beginning and traverse till the second last node, which means depending on the size of linked list n, your time is going to vary. So time is order of n linearly depending on the time, the length of your linked list, the time used will also increase. That is what is order of n. This is because you have to traverse from one end of the list till the other end of the list. What about the space complexity? For deletion, you are not using any additional space. Space complexity will be order of 1. So time complexity is order of n and space complexity is order of 1 for deletion at the end of a linked list. Next is the last case we are going to consider. It is deletion at a specific position in the linked list. Instead of beginning or end, let us say you want to delete from any specific position in the linked list. Here I am considering that I want to delete at position 2. That is position 0 is this, 1 is this, 2 is this and 3 is this. I want to delete this node which is having value 10. How can you delete this? For this, again, I have to start from the head pointer. What will I do? I have to traverse till this position. Is it right? No, you should not traverse till the point you want to delete. Instead, you should traverse till one position lesser than the position you want to delete. So instead of traversing till 10, you will stop your traversal at 21. That is, you want to delete at position 2. So you will traverse till position 1. Once you reach position 1, that is one position before your target position, what should you do? You should update the next pointer of the present node to skip the next one. How can you skip the node to be deleted? Whatever be the next node, that should point to whatever is next pointing next. That is, whatever was previously your next of next, that should now directly pointed by the next of this node. That is, what is previously next of next? Next of 21 is 10. Next of next is 17. So instead of making 21 point to 10 and then 10 point to 17, what will you do now? You will make 21 directly point to 17. This is how you are going to delete this node which is having value 10. Again, the same thing that we discussed in previous cases of deletion. Keep track of this node before changing this pointer. Because once you make 21 to point to 17, that is next of next, after this, there is no coming back. That is, you can't come back and keep track of 10. Because of this, before making this change, always remember that you should have a temporary pointer which will keep track of 10. After this, it is safe to remove this pointer, make 21 point to this. This is the logic to be followed. What is the time complexity here? The time complexity in this case, in the worst case, whenever you are discussing about time complexity, always keep in mind that you have to consider the worst case time complexity. So worst case time complexity here is, in case you want to delete at the end, that is position is end, then you have to traverse from the first node till the last node, that is second last node. Still it is order of n. So your time complexity for deletion at a specific position in linked list is order of n. And what about the space complexity? Space complexity is order of 1 only. The reason is you are not using any additional space here for deletion. So it is constant space operation. One more thing you have to keep in mind here is whenever you are deleting from a specific position, always make sure that this position is valid. Your position should not go beyond the last element of linked list. Then it is not a valid position. So make sure to check that the position is a valid position and then only go forward with delete operation. One more thing that I want to discuss is in the previous case of deletion, that is deletion at the end, we told that time complexity is order of n. When we were learning about insertion, we learned that is when deletion is done at the end. Okay. For this particular case I'm discussing now, for deletion at the end, we learned that time complexity is order of n. When we were discussing about insertion, we had told that if your insertion is to be done at the end, then there is a way by which you can make this as order of 1 time complexity. What is the method? For that, you had to keep track of the last node of your linked list with a tail pointer. Similar to the head pointer you are having, if you maintain a tail pointer which will keep track of the last node of your linked list, then insertion at end can be done in order of 1 instead of order of n. This is what we learned. Coming to deletion at end, is the same logic applicable? That is, can we do deletion at end in order of 1 time if we are having a tail pointer? Is this possible? The answer is no, it is not possible. Why is it not possible? It is because in case of insertion, you wanted to reach the last node if you want to insert at the end. So tail pointer helped you. But in case of deletion, the problem is you have to reach the second last node. Here, even if you have the tail pointer, there is no way to come back to the second last node. Tail pointer will only take you to the last node of the linked list. So in order to reach second last node, the only option is start from the head pointer and keep traversing till you reach the second last node. So in case of deletion, that is deletion at end, even if you are having a tail pointer, still your time complexity will be order of n. So what did we learn about deletion? About deletion, if it is at beginning, time complexity is order of 1. If it is at end, time complexity is order of n. And if it is at a specific position, then also time complexity is order of n. Coming to space complexity, in all these cases, space complexity is order of 1. This is what we learned about deletion. In the next lecture, we'll try to see how to write a code for deletion in linked list. We learned what is the process, but whenever we learn about any algorithm, any process, we should be good enough to convert this into a code. You should be able to implement it. So in the next lecture, we'll see how to write a code to delete a particular node from a linked list.